Yeah, welcome back to Galactus Academy. So we will continue with topic for today, which is mirrors. Yeah, so we'll be treating the images formed by mirrors. Then after which we're going to treat questions as usual. As other lectures, we will always start with an outline. So our outline for today is let's start. We have no time. Okay, we'll first of all lay some foundations. So we have to explain what the concept of reflection, right? Okay, the concept of reflection. We'll also proceed to talking about plane mirrors. All right, so we will also talk about the curved mirrors too. Yeah, they're very important. Curved mirrors. We'll also discuss some ray diagrams and the rest. Okay, I think that should be included under the curved mirrors. And then lastly, for the concept, we'll talk about mirror formula, right? And then most importantly, questions upon questions. So as to test our understanding. So basically, this is the pathway we are going to follow, right? So now, why do I decide to start from the concept of reflection? Okay, now, it's for you to understand mirror, in short, for you to understand everything, you have to know how it originates from, or what principle it's actually operating on. And that principle is what is reflection, right? So what exactly is reflection? So reflection, now when you hear reflection, this is a very, very straightforward term. I understand. But what exactly does reflection mean? Now, in my own terms, reflection is a phenomenon that takes place in a mirror, right? So for a fact, we know that it takes place in a mirror. But is it only mirror? No, it also takes place in polished surface. Polished surface, right? So I'll come again. Reflection is a phenomenon that takes place in mirror or polished surface, right? But one condition has to be met. One of the sides has to be coated. Do you get? So if this is a mirror now, and this guy is trying to view himself, right? So I have to coat this particular part so that he will be seeing his reflection. Exactly. So now mirrors are basically in different, will I say different forms? Yes, they are basically in different forms, right? The one you all know, which is, yeah, just the three of them are very, very popular, and I'm very sure you have an idea of what it is. So the first one is the plane mirrors, right? These are the ones most of you have in your houses, right? The plane mirrors. So we also have the concave mirror. So these are the ones used by dentists, and the rest like that. Also, we have convex mirror. So the convex mirrors. Exactly. Okay. So I'll come again. Reflection, you know what it means. These are the forms of mirrors, right? Okay, now let's talk about the laws of reflection, right? So what are the laws governing it? Now, basically, there are two basic laws. There are like two basic laws. Exactly. The first law is that the incident ray, the reflected ray, and the normal all lie on the same plane. Now, don't cram it. Do not cram. Just try to know it. Now, this is the plane. This is a mirror. So the incident ray can be in this form. Yeah, the incident ray can be in this form. Exactly. The incident ray can be in this form. So why the reflected ray will be in this form? Hmm? Now, the normal is perpendicular to the surface. This is the normal. This is the incident ray, right? No, put it, but this is the incident ray. Why this is reflected ray? Reflected ray. So now, the first law again state that the incident ray, which is this, the reflected ray, right, and the normal all lie on the same plane. This is the same plane. Now, what are the second law? The second law states that the angle of incidence, this is the angle of incidence, right? So it's equal to the angle of what? Reflection or reflected ray. So the angle of incidence is equal to the angle of reflection, meaning that I degree is equal to what? R degree. So equals to maybe theta. The same thing. Do you get the concept? Do you get the concept? Okay, now let me try cleaning this part. Okay, let's talk about plane mirrors real quick. Okay, now you already know what plane mirror is, so we will not dwell much on that saying of plane mirror is this, plane mirror is that. We know that it works on the principle of reflection. At least you should know that. Now let's talk about the characteristics. That's the most important thing that JAM is going to test you on, right? The characteristics. Now the characteristics of image formed by plane mirror. The characteristics of image formed by plane mirrors. What are they? What are they? Now, just imagine yourself looking at the mirror now. What are some of the characteristics of the images that are formed? Yes, correct. Same size. Same size as the object. Right? Same size as the object. Right? So what else? What else? What else? True. Equal distance. Equal distance. So, or same distance or equal distance, anyone you try to use. Equal distance between the mirror and what? Between the mirror and the image. Now, this is what I'm trying to say. You know, when you are looking at the mirror, your image is like somewhere here. You get? So you are here. Okay, no need of putting you are here. You get? So what I'm trying to say is that this size is equal to this size, and also the distance between this part and the mirror, that's the image that is being formed and the mirror, and the object that is you in person and the mirror is the same. It's equal. Do you get that? It's equal. Now, that's one thing you have to take note of. Now, what kind of image is formed here? In our previous video, I actually explained to you what virtual and real image is. Yes, I did justice to that. So what kind of image is actually formed here? A virtual image. And why is it called a virtual image? Because cannot be projected onto a surface. Now, the image that is formed in this place, it cannot be projected onto a film. Exactly. It cannot be projected onto what? Onto a film. So it's virtual. Also, have you noticed that if you try lifting your right hand, while facing a mirror, the image that is being formed, it will seem as though you are lifting your left hand, okay, your left arm. Why is this so? It's due to a principle known as lateral inversion. So in plane mirror, we actually see what? Lateral inversion in play. So the left becomes the right becomes the left, something like that. Exactly. Also in letters, the last becomes the first, right? The first becomes the last. So please take note of this principle. They ask it a whole lot. Exactly. So these are, and also the image form is upright. I know you might be saying that, why do I need to include upright? Is it not supposed to be upright? Yes, I have to include it. When I proceed to curve mirror now, you see that some of the images form are actually what? Are inverted. Most of the images form are inverted. So if you're in an option, if you see upright as the part of the characters of plane mirror, please go ahead and choose it. Do you hear? Go ahead and go for it. All right. Now, there's another principle you have to note. Some mirror can also be inclined. Like you can actually place two mirror, right? Like at an angle for a specific purpose. Exactly, for a specific purpose. And I will tell you some of the application of placing or using an inclined mirror. But there is something I want to draw out of this concept, which is the number of images that are formed. You know, once if we have only one mirror, we expect only one image to be formed. But when we have two mirrors inclined at an angle to each other, the number of image produced will not be constant. It varies. It largely depends on the angle. You get it largely depends on the angle. All right, but now how do we know the number of images that are formed? Now take note. The number of images formed depends on the angle. This angle here. It depends on the angle between the two mirrors. Now, whenever you are asked this question in exam hall, use this formula: 360 divided by the theta, that's the angle, minus 1. Is that very clear? So this formula should not depart from you. This formula should not depart from you. Always have it at your fingertips. Okay, moving up front. I want you to know something. You know, the first law of reflection, when I was treating the first law of reflection, I said the ray of incident, the incident ray, the reflected ray, and the normal all lie on the same surface. But in some cases and in some application, we can actually adjust the mirror. We can actually adjust the mirror just to check out something. There's an application. You know, physics, you don't just do things. There is a specific purpose, there's a specific reason why we take certain actions. Exactly. Now, when we okay, now let me not make things vague. Now, what I'm trying to say is this. This is a plane mirror, right? This is a plane mirror. This is the incident ray. In some cases, we can actually shift this mirror. Exactly, so that it becomes maybe something like this. Exactly, so that it becomes something like this. Now, you know, this thing has actually been tilted by an angle. How do we know what this angle is? How do we know? Now, get your book and pen and write this. Okay? Whenever a mirror is rotated through an angle, the reflected ray always rotates twice. The reflected ray or the angle of reflected ray, let me just put it this way, right? Always rotates twice that angle. You know, we know that I normally is equal to r theta, that the angle is equal. But when it's tilted, you get this r theta, the r theta, which is the angle of reflection, exactly, will now be equal to 2 times the angle by which it is being rotated. So if I say, oh, I rotate this mirror, this particular mirror, right? If I say I rotate this particular mirror, right, by 5 degrees. So what will be here will be 2 times 5 degrees. Do you get the point now? Do you get the point I'm trying to make? Now, let me make it practical and show you some workings. This might put you through some things. Okay, let's assume we have a mirror like this. Okay, let me see. I'll just make it right. Okay, and this is the incident ray. I'm coming from below. So I tilt this to be like this. I tilt the mirror to now be in this direction. Exactly. Through an angle of what? This angle is what? Theta. Let me use a black pen so that you able to. This angle is what? Is theta. If this angle is theta, definitely this is what? Opposite angle are equal. Exactly. Now, we also have normally we have the reflected ray to be like this, and then the normal. But when I let me use this one. This is the new orientation of the mirror. Now, if I keep this incident ray constant, right, I expect the what do you call this? The second part, that's the reflected ray, to be more further, right? To be more further. This is the first reflected ray, and we also have the normal here. This is the normal too. This is the normal one. Do you get the approach I'm making? Now, this is the first incident ray, right? This is the normal reflected ray. This is the normal. But now, when I rotate this mirror, right, we expect a new reflected ray to actually exist, right? So, which is this? Do you get? Which is this? Do you get the point? All right. Now, if we are having a new reflected ray, then we expect to have a new normal. So, this is a new normal. Do you get the point now? Okay, now, how do we know um the angle? Because before now we have an idea that this is I, right? We also have an idea that from here to here is actually what? R, or let's say I. Okay, but things have changed now. Okay, from here to here, right? From here to here is what is rotated through an angle, which is what? The theta. Exactly. Is rotated through an angle, which is what? The theta. This particular part is theta. Do you get the point? This particular part is what? Is theta. So from this particular point to this point is what? The theta. And that's the reason why they said the new reflected ray will now be what? To theta. Now it looks very vague, but when I start solving question, you'll be able to like relate it. You'll be able to what? You'll be able to like relate it. But just take something away from here, which is that the new angle between the incident ray and the reflected ray, right? The new angle between reflected ray, and the incident ray is equal to 2I plus theta. Just know this for a fact, right? The new incident or reflected ray. So meaning that if this is 2 theta, and we know that it has to be equal, then from here to here is what? I plus theta. While from here to here is also what? I plus theta. Meaning this theta that is here can also be represented with what? With I. They get. But do not worry. It looks vague, but we're coming. We're coming. Just stay tuned. Now let me tell you some of the applications of mirror, right? Some of the applications of mirror that you have to take note of. One is the periscope, right? One is the periscope, right? First off, what is periscope used for? Periscope is simple. Periscope is used for observing objects above or below the normal level of vision, right? And how does periscope look like? So if you have seen a submarine, it will not be vague. You should have seen something like this in a submarine. So this is the eye. This is the eye. This is the eye, and is looking through here. It expects to see something, right? So now in periscope, we have two mirrors inclined at a plane to each other, right? Now this plane mirror is inclined at 45 degrees to the horizontal. So it's inclined at what? 45 degrees to the horizontal. This is how it's placed. 45 degree to the what? To the horizontal. But they are what? More like parallel to each other. This is one mirror. This is another mirror. Right? They are parallel to each other, meaning that if ray is coming from this part, it hits here, bounce here, and then the navy can actually see what is going on outside. Exactly. We can see what is happening. Now, know this and know it very well. The angle between one of the mirror and the horizontal is what? 45 degree. But they are parallel to each other. The mirror are parallel to what? To each other. And when they are parallel to each other, it can either be 180 degree, you can either go 180 degree or 0 degree. Now, you should know that one thing, what is happening here is that one image is produced. Exactly. Now, because from the formula 360 divided by 180 minus 1, this is 2. So 2 minus 1. So one image is produced. But due to the fact that they are parallel, right, we have fainter images being also produced. You get? So that's for periscope. Do not forget. Now, the second one, kaleidoscope. Now, as children, we actually use this. I think I should attach an image. Kaleidoscope. Now, there's this camera we have as a child, right? It's like this. I don't know. When your eye, this is the place you view what is happening. So when you click this, right, you can click this. When you click it, you see different image. You click it again, you see another image. You click it again, you see another image. You click it again, you see another image. So that's like an application of the use of play mirror. They get so just something like that. Now in kaleidoscope is very, very easy. For kaleidoscope, the two mirrors are kept at 60 degrees to each other. So this one is very straight, 60 degrees to each other, not to the horizontal or all those rubbish. So 60 degrees to each other. And if they are inclined at 60 degrees to each other, what do you expect? How many images do you expect it to produce? Now, go back to your formula. 360 divided by 60 minus 1. What do you get? Correct. 360 divided by 60 is what? First off, we'll give you 60 now. Yes, now. So 66 minus 1 will give you what? 5. So 5 images are produced here. Right? 5 images are actually produced in kaleidoscope. Do not forget that. Now, why do we use kaleidoscope first off? Actually, 5 images are produced. Why? Okay, now, write this. Because it produces symmetrical patterns. That's number one reason why it's being used. It produces what? Symmetrical patterns. And also, it can also be used in textile industry, right? Or among textile designers for producing color patterns. Is that very, very clear? Now, another application of mirror, of play mirror to be precise, is sextants. Now, but yeah, sextants is something that every one of you should know. So sextant is used in navigation, right? It's used in navigation and also in finding the angle of elevation of the sun. So it's used in navigation and what? Angle of elevation. Angle of elevation of what? Of the sun. Is that very clear? Also, another use of plane mirror is in mirror galvanometer. Mirror galvanometer. So now you understand what galvanometer means. So galvanometer is simply an instrument used in measuring like very small current, really, really small current in millisecond in milliamp, you know. So mirror so now so plane mirrors can also be used in this. No, not in the traditional sense of you attaching a wire, having a magnet as at its core and the rest. No. Do you get? So this kind of mirror galvanometer has no physical pointer. So there is no physical pointer here. Right? There is no physical pointer here, right? But with the principle of rotation of reflected ray, that's what it works on. It works on the principle of what? Reflection, the principle of rotation of reflected ray, the principle of rotation. So rotation of reflected ray. Is that very clear? Also, it's another use of plane mirror is in color combination. There are color combination and what is called this theoretical stage, right? So like this theoretical stage to produce some illusions, some optical illusions, like for instance a candle burning inside bottle of water. You know, in acting movies, this plane mirror can actually come in handy, right? So let's talk about curve mirrors. Yeah, curve mirrors, curve mirrors, curve mirrors. All right, so there are two basic or two most important curve mirrors you should know. The first is the concave, and the second is what? The convex. So the concave and what? The convex mirror. For concave, we know that is what? Converging. It's converging. That's it applies for mirror only, because when we get to lens now, you know that concave is actually diverging, but let's leave that for later. We'll come to that later. So convex is what? Diverging. Do you get it? So just know this for a fact. Know this for a fact. And what else do you have to know? You have to know the essential part of the spherical mirror. Yes, the essential part of spherical mirror. The essential part of what? The essential part of spherical mirror. Now, let me draw a diagram so that you will be able to flow what I'm trying to say. So this is spherical mirror. Don't mind my diagram. Just trying to so this is spherical mirror. Exactly. So from this part, AB, let me call this AB. This AB is what? The aperture. Is what we call what? Is what we call the aperture. Exactly. Now, this part here, let me use a black pen so you see what I'm trying to say. This particular part is called what? The pole. Right? So, the pole is simply regarded as the center of the reflecting surface of the curved mirror. Exactly. Now, we also have the center of curvature. Let me see where I'll put it. Yeah, okay, yeah, it's not bad. So the center of curvature, which is represented by C. Exactly. Center of curvature. C, center of curvature. Right, center of curvature. Now, the center of curvature of the sphere is now this. I call this curve mirror, or let me say spherical mirror, right? Meaning that there was once a time that it was a normal sphere, like it was really a normal sphere, and then we kind of divided it, right? That particular point in which it was divided, that point is called what? The center of what? Of curvature. Exactly. So it's simply regarded, we can also say it was the center of the sphere from which the mirror forms a part. Exactly. Now we also have the radius of curvature. Now, radius of curvature. Radius of curvature is PC. Radius of curvature is simply the distance from this place to this place. That's the radius of curvature. Exactly. That's the radius of curvature. Now, the principal axis. Yeah, the principal axis. Most people actually do not really get or not even understand what the principal axis means. Now, the principal axis is simply a line drawn from the pole to the center of what? Curvature. So this line here, let me use the black pen so you will see it. This line here is known as what? The principal axis. Exactly. This line here is known as what? The principal axis. Do not forget. Now, another thing is very important, or there's something else you need to know, which is called the principal focus, right? The principal focus. So it's regarded as F, we denote it as F. Now, the principal focus is equal to, before going to the formula, let me tell you what it is. Now, it's simply a point where the rays parallel to the principal axis converges at after reflection in a concave mirror, or the point at which rays appear to diverge from after reflection in a convex mirror. Yeah, that's a lot of information. Calm down. That's what I'm here. I will explain. Okay, now when rays actually can can be transmitted parallel to the principal axis. But now when they hit this part, this way they actually deflect to, right? So we can take this to be the incident ray and take this part to be what? The reflected ray. Do you get the point I'm trying to make? So this is the reflected, this is the incident ray, reflected ray. So any ray parallel to this principal axis must be reflected through what? The principal focus. And the principal focus, which is F, is equal to R over 2. It makes sense. Exactly. It's equal to what? R over 2. And it has been proven to be correct. Exactly. It has been what? it has been proven to be correct. Shall I clear this place or shall I? Okay, let's talk about ray diagrams. Let's talk about ray diagrams. Ray diagrams. Now, ray diagrams. When I talk about ray diagrams, what we are going to major on, right, is actually the images formed in a curved mirror. The images formed in the curved mirror, and constructing ray diagrams, you have to know some of the rules that come into play. They are not much, right? I just memorized only two, and those are the two I feel are very, very important. One is that the rays parallel to the principal axis are reflected through the principal focus. This is what I explained here. Let me use a black pen. So the rays parallel to the principal axis are what? Are reflected through the principal focus. Is that very clear? And vice versa. Is that very clear? Okay, and secondly, rays passing through the center of curvature. The rays passing through what? The center of curvature. Let's assume that the ray is going like this. Right? The ray passing through the center of curvature are reflected back along its path. So it means that the reflected ray and the incident ray and the reflected ray are along what? The same path. Is that very clear? Okay, so that's the two major stuffs you have to take note of. Now, images formed by concave mirror. Let me start on a new page. Right, images formed by concave mirror. Images formed by a concave mirror. All right. Now, there is a principle you have to note is that the image form is heavily dependent on what object position. It's heavily dependent on what? On object position. And you have to take note that as the object approaches to the focus, I will explain it. Calm down, just don't worry yourself. As the object approaches towards the focus, the image becomes bigger and moves away from the mirror. Now, this is what I'm trying to say. Now, let me just give you a glimpse of what I'm trying to say. Now, you already know what all this means, and the rest. This can be C, this is F, this is P, this is okay. Now, rays can be coming from this part. Exactly. Right, rays from infinity can be coming, right? So when they are coming from this part, it actually forms a diminished image, right? A small image. Do you get the concept? It's actually what forms what the small image at what? At F. At F. Now from infinity. But when I get closer, let's say beyond C, when I go beyond C, right, what the image form will now be between what? F and C, and a little larger than this. When I come out, when the image is now at, so now this is where it is, right? When the image is now at C, what is formed is the same size of image at the same point at C, right? When I now get to this place, what is formed is an enlarged image, right? Inverted, but is beyond C. Do you get the concept? Now, when it's at F, it now becomes at what? Infinity. Very large. Very large. Now, when I get closer, that is between the pole and the principal focus, right? What do I get? I get an erect image that is magnified. Exactly, but it's virtual. Now, you don't need to really know how to construct the ray diagram because it requires a whole lot of we have to use a graph to get it correctly. So I'll just give you a concept you need to know to pass the exam. That's the images formed by a concave mirror. What you need to know to pass your jam, just to pass it. Exactly. So now there are 5 kinds of images for me. I use 5, I just memorized 5. Now there are 5 kinds of images that can be formed here in these instances, right? The first one is one, object at F. Object at F, right? So object at F will form, that is at this point, let me use a black pen. So this is where F is, this is where C is. So object at F will form an image at infinity, right? Will form an image at what? Infinity. Also, it also form a real image. It also form an inverted image that is magnified too. Okay, now just take note of something. Whenever the image is inverted, therefore it will be real. So real and inverted go hand in hand. Whenever it's inverted for concave, it will always be what? It will always be real. Don't forget that. All right, number 2. The second type of image is formed between F and C. Right? Between F and C. So what kind of image is formed between? When it's between F and C, it forms beyond C. The image forms beyond C. Right? The image formed beyond C. It is real. If it's real, then we have to know that inverted has to follow. And what is magnified? Beyond C. And is what? Magnified. Is that clear? All right. So at C, when we place the object at C, what I tell you here, I explained it here, that the image will form at C too. Is that clear? So the image will form where? At C. The image will form at C. It will be real. The image will form at C. It will be real. If it's real, then it will be inverted. Inverted and same size. This is the only place you see same size. Same size. Sorry, size. Same size as the object. Do you get? All right. Now, what about beyond C? What have we beyond C? What do we get? Yeah, just copy this, please. Just copy number 2. So now we have 4, which is beyond C. We have beyond C, right? So for beyond C, it will form between F and C. Do you get the principle I'm using now? Between F and C, it will be real. It will be real. It will be inverted. If this was magnified, what do you expect it to be? Tell me, you know it. What do you expect it to be? Diminished, correct? Diminished. So, and lastly, is when it is between F and the pole. Between F and pole, that's F and P. Now, the image form is formed behind the what? The mirror. Now, all this image here form in front of the mirror. But now, the only place it's going to form behind the mirror is when the image is placed at this point. That is between F, that's the principal focus, and the pole. Do you get that? You get the pause? You get it now? Good. So behind the mirror, and also if it's formed behind the mirror, it means that the image is what? Virtual. Exactly. Not only virtual, it's also erect. For it to be erect, it means that there will be some applications, but we'll come to that. Don't worry yourself. So erect and what? Magnified. Now, these are the 5 these five are what you need to get at your fingertips. It's very important. I get it. You need to have this at your fingertips. Now, they can ask, okay, when the object is at infinity, what is formed? That is, they just try to reverse the first question. Okay, when the image is at infinity, what kind of when the object is at infinity, what kind of image is formed? Use your brain. Now, the image will form at what? At F. They get that it will be what? The image will form as what? At F. Exactly. It will be inverted. Know that. It will be inverted. It will be real, but it will, what? It will be diminished. So it's only diminished that has opposite magnified or diminished. That will be changing. Now, if we have an image that is placed, let's say between F and C, you know what is formed. It's placed beyond C, you know what is formed. So that is, I think this should serve as a very clear concept. Okay, now let's know the kind of images that are formed by convex mirror. If you have any question, please type it in the comment section. Type in the comment section so I can go through it. All right. So the image is formed by concave mirror, by convex mirror. Let me clear the space a minute. So the image is formed by convex mirror. Images by convex mirror. This is the easiest. This is the easiest. Only one type of images form. One characteristic of images form. Yes. Yes. So convex mirror forms only virtual, erect, and diminished image, regardless of where you place the object. That is, it does not depend on the object. If I place it in Jerusalem, if I place it in Italy, the same characteristics of image will be formed. Exactly. The same characteristics of image will be formed. Now, let's talk about the applications of curved mirror. Applications of curved mirror. Now, for curved mirror, concave mirror are used as shaving mirror. Do you understand that? So, concave mirror can be used as what? Concave mirror. Let me just write it here. Shaving mirror. But you know, when I was explaining concave mirror, I told you that where you place the object matters. Unlike convex, where you place the object matters. Now, I know you are very smart. Where do you think the person shaving, the man shaving, will place his head? At what point? Can you try? Try, just try. Okay, good. I believe you got it. Now, it will place between the pole and principal focus. Why? Why? We have to place it at this point because we have to get what? Erect. We will get what? An image that is what? Erect. Other parts will always give an inverted image. So it's not going to be nice if we're shaving and then we're seeing an inverted image. Could make sense now. Now. Could make sense. So just know that it has to be placed at that point. And also it can be used by dentists. It can be used as what? Dentist mirror. Dentist what? Mirror. Alright, what of convex? Convex. Now, for those of you whose father has car, you're going to see something. If you check if you are less busy, go outside, check the side of the car. You see that there is where the road images, how does the object appear? They do write it like this: object appears closer than they appear, than you are seeing it. Object appear closer than what that is being reflected. They get so now, why do you say that? And why do I have to bring that in? Now, convex mirror only forms virtual, erect, and diminished image. They get so it is used as what? Driving mirror to see a wider range, a wider view, right, of vision. To grant a wider view of vision. So you can actually see some vehicles that are far behind, that are like adjacent to you, but a little bit farther from where your eyes can capture. That kind of thing. Exactly. So it's used as what? As driving mirror. It's used as what? As driving mirror. Why do I say they are used as driving mirror? One is because what most importantly is that they give a wide field of vision. Exactly. But one major disadvantage I need to say of convex mirror is that it gives a false impression. Disadvantage. False impression of distance. False impression of it gives a false impression of distance as images, right, seem farther away. They appear farther when you're looking at the mirror, but meanwhile they are closer than you think. Exactly. Hey, concave mirror can also be used what in like as a reflector. Yeah, concave mirror can also be used as a reflector. Yes. What I mean by this? What I mean by this? For those of you who study high, you got this telescope, right? This telescope, it works on this principle of reflection and reflection too, right? So we have to study some galaxies, right, which are very far away. So you can say that okay, these galaxies are at infinity, right? These galaxies are at infinity. So we try to converge that light, that ray from infinity at a point which is F. Exactly. So these reflectors are used in what's called telescope. Exactly. So concave mirror are used in what? In telescopes. Is that very clear? Are used in what? In telescopes. All right. Let's talk about the mirror formula. Now, the mirror formula. The mirror formula. Now, this is something that almost every one of you know as the basics of physics. You know, the now it's very simple. Just know it's 1 over F is equals to 1 over V plus 1 over U. What does F stands for? What does F stands for? The F stands for what? The principal focus. You know, V stands for what? The image distance. The image distance. The U stands for what? The object distance. It's as simple as that. Now, these values are positive in most cases, but whenever we have a virtual image, whenever we have what? A virtual image, our V will be negative. Exactly. And for convex mirror, our F and our V will be negative. You get, but don't worry yourself. We'll soon start teaching questions now. So when we start teaching questions, you are going to see all these come into play. Exactly. Now, what of magnification, right? We have formula for magnification. Magnification is simply V over U. It's also equal to image height over object height. I think we actually treated something like this. Yeah, we actually treated something like when I was treating. Yeah, we actually treated something like this. So object height over what? Image height over what? Object height. Okay, then now let's try to combine certain things. You know, solve some things and try to see how the combination can actually work. Okay, if we have 1 over F equal to 1 over V plus 1 over U, exactly, and try making with 1 over V, so in the formula, we are going to have something like this. 1 over V equals to 1 over F minus 1 over U. Now, trying to get the, what do you call, the LCM for this, just put the FU here. So we have our U and then minus F equals to this. Exactly. So equal to 1 over V. Now, making V stand alone, we'll just flip it, meaning V is equal to Fu over U minus F. So hold this formula is to come into handy in future. Exactly. Okay, what else? What else? What else? What else? Okay, now we can also use this. M is equal to V over U. We know this already, right? So from here, V is equal to this. So let's just impute it and see how things turns out. Okay, over U minus F. Exactly. Do you get the angle I'm actually coming from? I believe you should. I believe you should. So U will cancel U. So we're going to end up having F over U minus F. Exactly. F minus U minus F. That's for M. Let me just write it here. Just to put things in order. F minus u minus f. Is that clear? So know this too, know this. All right, so we also have we can also have like something like, okay, this u. What if v was given? What if v was given? So m is equal to v over u, right? So we have our v. Yeah, we have our v, for instance. So we can, for u, okay, now just try to make use of a formula, right? Try to make use of a formula and then put it into the formula, right? So what I mean by this is that, like, try making use of the formula here, right? You should get something of this nature, but instead of getting yeah, you should get something of this nature. Exactly, something of this nature. So I'll just change this u to v, then this v here to u. Basically what I'm actually doing now. So I'll have fv over v minus f, which is equal to v over 1 v minus f over dx. Like this one will have to come up. Exactly. I'm skipping a whole lot of steps because I believe you guys are big boys. So just to make things faster, right? So this we cancel, this we cancel this. So we'll end up having v minus f over dx for m. Exactly. Now, there are some graphical representations too. There's some graphical representation, and they work on the principle of this y equals to mx plus c. This is something you should know in in some of the equations in mathematics, right? So now, if we have something like this, like, yeah, something like this nature. Let's say 1 over u, right, equal to 1 over, okay, minus, okay, what's related to this? How do you think we're going to present it? Now, just there are some I have to prove it, and just like I told you and I assured you that we are trying to get things straight to the point, so I'm not going to prove it. I just need you to cram it, right? Cram it. Now we have 1 over v, right? And here what? 1 over u. This is the y-axis, this is the x-axis. So if we are to relate it here, this is the y, right? So it means that we can also have 1 over u here, 1 over v here. It doesn't matter. They can act interchangeably. So whenever I see something like this is how the graph will always be like, right? This is how the graph will always be like. So meaning that the slope will be given there, right? The slope will be there. Okay. We um also have, let's say, let me see where I'll pick my equation from. Okay, now let's have this. We have m equal to v minus f over f, right? We know this. And since it's like this, we can have it as v over f minus 1. Do you know it goes 1? I just like separated this part, meaning v over f minus f over f. So f over f 1 dx. So our m is still retained. Exactly. So basically this will work, right? So let's make it more easier so you'll be able to understand. So it's equal to 1 over f open bracket v minus 1. Like open bracket v minus 1. So now how will the equation be like now? We have our x to be this v, our y to be m. So this is how it's going to be like, right? And since it's coming from minus 1, that's the intercept. You get, so minus 1 here. So it's going to go up this way. Our m will be here, and our v will be here. The slope was 1 over f. Do you get it? The slope was 1 over f. So I just need you to like have these at your fingertips. You get, have these at your fingertips. Now let's go over to questions and treat some questions. Okay, so we've actually set the foundation. So let's treat some questions. So we have the first one here, which of the following diagram shows the correct images of the letter JP as seen through a plane mirror. This shouldn't be hard. This shouldn't be difficult, as I've explained to you some of the characteristics of images formed by a plane mirror, and amongst them is one which stands out, which is what? Lateral what? Inversion. Right? Lateral inversion is one that actually stands out amongst others. So I've talked about what it means, right? Meaning that the left become the right. It's just flipping over. Exactly. In we have, let's say we have this x-axis, this x-axis, this y. So the lateral flipping is actually on the x-axis, not on the y-axis. But when we're talking about inverted erect, it's actually flipping in the what? In the y-axis. Do you get gist now? Do you get the point? Okay. So if we have JP, it means that we have to flip it, right? We have to flip it. The first become the last become the first. So now it has to be something like PJ. That's like starting point. But is it really PJ? No, it's not going to be PJ per se, right? It is lateral inversion. So this place should be like this, like 9, and here should be like this. Do you get it? Which correlate to option which correlates to option A. I feel this is very clear now. So option A is correct. So we have another question. This is more technical, but it's relatively easy. So let's draw the diagram. Let's enlarge it so you can have an idea of whatever I'm doing. Okay. Okay, so this is 30 degree. Let me read the question first. In figure above, what is the angle of reflection of the ray of light at mirror 2? Okay, so this is mirror 2 and this mirror 1. So we are told to find the angle of reflection, exactly, which is this angle, x. Exactly. So how do we get it? Let's solve. So if it's 30 degree, what will here be? We don't know for now. Yeah, what will here be? Here also be 30 degree. Why did I say it's going to be 30 degree? Remember the second law of reflection, where I said that the angle of incidence is actually equal to the angle of reflected ray. Do you get? So this is simply the incident ray, and this is what? The reflected ray. Do you get? This is reflected ray. But that's pertaining to M1. But when we're talking about it in related to M2, this will become what? The incident ray. Why here become what? The reflected ray. Exactly. Okay, so with that concept established, let's understand, let's know what here is. So this, go back to the normal formula we used to use, 2x, angle on a straight line is what? 180, right? So 2x plus 60 is equal to 180. So 2x is equal to 180 minus 60. So x is equal to 120 divided by 2, which is equal to what? 60 degree. So here is actually 60 degree. Here is 60 degree. What do you expect here to be? 60 degree. Opposite angle are equal. Is that clear? If here is 60 degree, understand what here is. What does this angle look like? 90 degree. So 90 degree minus 60 degree. 90 degree minus 60 degree should give you what? 30 degree. Is that clear? So this 30 degree. I is equal to r. So if this angle here is 30 degree, we expect here to also be what? 30 degree. So finally, x is equal to 30 degree. I hope this is clear enough. All right. So as I always advise, try as much as possible to engage with whatever I'm actually teaching. Do not be a spectator. Engage. How do you engage? Getting a book and pen, pausing a video before checking out the correction. Solve. That's the only way you learn. All right. Let's have this question. Which of the following diagram below represent the relationship between M and V for a converging mirror? I've actually talked about this when talking about when establishing the concept. Okay, so we have something at hand here, which is a relationship between M and V. M and V. Which formula actually denote this? If you can remember, we have M is equal to V minus F over F. We actually proved this. We've proved it already, right? You can scroll back to have a glimpse of what I did. I don't want to start the process all over here again. Okay, so now let's solve V over F minus F, right? So M is equal to okay, sorry, here it's a 1 over F minus 1, exactly. So let's relate it to this equation. So our y will be M, that's correct, that's true for everything. Our x will be V, that's true for everything. But now we don't know how the slope will be, how, that kind of stuff. And how do we get it? We actually get it from this part. This is what's called intercept, right? So it's actually the point at which it crosses the the y-axis. Are you getting? So now the intercept is actually -1. So meaning that it's going to look like this. It's going to start from here. It is -1. It's to start from what? This place, and then ascend upward. So which one is true here? This. This is what is correct. Exactly. Our x is v. I've explained that. So if you're asked the slope, maybe sometimes they might not want to go straight, or they don't want to bother themselves having diagrams here and there. They can just say, okay, what's the slope? What's the slope? So the slope is simple. Is what? 1 over f. Exactly. 1 over f. Alright, so now let's go to the next question. What would be the characteristics of the image of the object OB shown above after reflection from the mirror? Now, where is the object placed at? It's placed between the pole and the principal focus. Now, what's the characteristics of image from when we have when the object is between F and P. What characteristics of image formed? What is it? What the characteristics of image formed? Now, we have a magnified image. I told you that the closer the object gets to the pole, the larger it becomes, right? The larger it becomes. All right. So also, is it going to be real? No. It's going to be inverted. It's going to be virtual. I mean to say. And if it's going to be virtual, definitely it's going to be what? What's it? It's going to be what? Yeah, erect. Exactly. It's also formed behind the mirror. It's also formed behind the mirror. So please do not forget this. Take note of that. So what's the option? What's the correct option here? It's very simple. D. D is correct. Exactly. Alright, so let's go to the next question. Which of the following cannot be explained using the laws of reflection? Which of the following cannot be explained using the law of reflection? And I've talked to you what reflection is. Yeah, that's the phenomenon by which I've actually explained to you what reflection is and all. You know that it's a very core principle by which plane mirror acts. Right? It's a very core principle by which plane mirror acts. So formation of images by plane mirrors. Is that true? That's true, right? You are able to see your image because of the reflection it makes. What of curved mirrors? Yes, the same thing. Mirrors, the same thing. What of periscope? Action of periscope? Yes, it actually can be explained using the law of reflection. Yeah, yes. Periscope is simply the application of plane mirror, nothing else. It's simply the application of what? Application of plane mirrors. All right. Okay. Okay. Formation of shadows. Formation of shadows. Is that true? No. Now, when you're standing, let's say this is sun. Let's say this is sun. And then you're standing here, right? So your shadow will most likely be like this. So what is actually giving rise to this reflection, to this shadow? Is it reflection? Do you think it's reflection? If you say it's reflection, what's the reflecting surface? Where is the reflecting surface? So you can see that it's not actually reflection. It's due to a principle which I've explained before, rectilinear propagation of light. Rectilinear propagation. Yeah, rectilinear propagation of light. So please take note of this. An object is positioned between. So that's the answer for that, right? This is the answer D. Option D is correct. So before I move to the next question, let me just, for those who do not understand. Now, when they say rectilinear propagation of light, what does that mean? Rectilinear propagation of light just talks about or just talks about the transmission of light on a straight line. That is, when light travels, it travels in a straight line, not around obstacles or whatsoever. It travels in a straight line. So it casts shadows. Now, if it's not able to pass, like this is what it means. Let me just give you a glimpse of, if lights come in this direction, right? This direction, and it cannot pass through this door. Do you get that? But it can pass around, it can pass here. We are expected to see a shadow here, depending on how bright the light is. Do you get that? So it means that the light that does not pass through this door, that does not pass through this door, is not compensated by this one. Maybe this one come around, then brighten here up, that kind of thing. It does not happen that way. The only way, the only instance where we are not going to see a shadow, we're not going to see a shadow, is only when, like, the light is very, 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 very bright. I mean, extremely bright, and the door is not large enough. Yeah, yeah, that is a scenario where we're not going to have the presentation of a shadow. Okay, next question. An object is positioned an object is positioned between two mirrors. Okay, inclined at right angle to each other. Okay, so we know that the degree here is what, 90 degree. Okay, the object is 1 unit distance from each mirror. Okay, what the number of images formed is what? So we are asked to find the number of images formed. Now, what's the formula to get the number of images? This is very simple. It's actually n is equal to 360 over theta minus 1. As simple as that, ABC. Now, what's 360 minus, okay, sorry, 360 divided by 90, yeah, minus 1, yeah. All right, so 36, 360 divided by 90. Can someone help me calculate? It's 4, right? It's 4. Okay. So 4 minus 1 is what? 3. So we expect to see 3 images here. So the number of images formed here is what? 3. As simple as ABC. You can see that. You can see how physics is really, really simple. Yeah, it's really simple. You just have to put your mind to it, and you'll be awed by how easy it is. Okay, so Joy looked into a mirror which is 3.5 meter away. It's 3.5 meter away from her, and observe the image of a photograph. Okay, well, let's understand the question first before we write out anything. Which is 1.5 meter behind her head. What is the distance of the image? Okay, now let's represent the mirror. So Joy is at this point. So let's assume this is what she's actually seeing, right? Okay, so from this part to this part, we've been told that Joy looked into a mirror which is 3.5 meter. So this is what, 3.5 meters away from her, and observe an image which is 1.5 behind her head. So from her head to the object is what, 1.5 meter. Now, the principles of physics are always constant, are always true. Exactly. Now, let's go back to what you said during plane mirror, that the image produced is the same size as the object, and also is the same distance from the mirror. Exactly, it's the same distance from the mirror. So we expect the image, that's Joy image, to be the same as 3.5 meter, and also what she's actually looking at. Pardon my drawing. So what she's actually looking at will also be in the same what? The same distance, which is 1.5 meter. Now, this is where the challenge comes. What is the distance of the image from Joy's eyes? So this is where Joy's eyes is. This is where Joy's eyes is. So we've been told to calculate the distance from here to what? To the image, which is this place. Exactly. Meaning that we just have to add everything between, which is 3.5 plus 3.5 plus 1.5. 3.5 plus 3.5 will give you what? 7 plus what? 1.5, which is what? 8.5 meter. So option D is really correct. Exactly. Okay. A ray of light incident on a plane mirror at an angle of 30 degrees. A ray of light incident on a plane mirror at an angle of 30 degrees. It's just, I don't need to do any diagram to get this. If you really understand when I was explaining the rotation of a mirror, you should be able to get the answer without even thinking twice at all. Without thinking twice at all. Exactly. Now, we've been told to find the new angle of incidence. That was what we to find, right? And it's rotated through an angle of what? Of 10 degrees. Exactly. Now, the initial angle of this, like the initial angle of the incident ray is what? 30 degree. It's 30 degree, right? All right. So there's something I want you to note. You know, when I was explaining this particular principle, that when it's being rotated, let's assume this rotated position now, like I've rotated already, right? So I told you that this angle will become 1 I plus theta. Why here we call it I plus theta? Do you understand that? Do you get it? All right. So this particular part is what we have been asked here. So all you have to do is just add these two together and you get the answer, which is what? 40 degree. D is the correct answer. I hope this is clear enough. All right. Let's go to the next question. An incident ray is reflected normally by a plane mirror onto a screen where it forms a bright spot. Where it forms a bright spot. The mirror the mirror and screen are parallel and 1 meter apart. If the mirror is rotated through 5 degrees, calculate the displacement of the spot. Okay, let's understand it. An incident ray is reflected normally by a plane mirror. Normally. So let's assume this is the plane mirror. So it's reflected normally. So instead of us having something like this with the normal being here, it's not like that. We're only going to have just one one line, which is the normal. So let's take this to be the normal. Exactly. So this is where the surface which is coming to. Okay, let's take this to be S1. That's the first point, right? Let's take this to be F1, S1. So it's rotated through an angle. It's rotated through an angle. So let's take that this is a new angle. So this angle that is formed is 5 degrees, right? So this will now be the what? The new reflected ray. That coming to S2. Now, what do you think will be the angle here? Remember that the reflected ray is 2 theta, meaning 2 times 5, right? 2 theta equals to 2 times 5 equals to what? 10 degrees. So here should be what? 10 degrees. Exactly. Now, remember the information it told us, 1 meter apart. What this 1 meter apart is from which way? The mirror and the screen. The mirror and the screen. All right, so 1 meter. Now we've been told to find something. If the mirror is rotated through 5 degrees, all right, calculate the displacement of the spot. This is the displacement of the spot they are trying to find. Let's take this to be x. Now, to get the formula we're going to use to get this, right, we have to go back to our normal basic mathematics, which is SOHCAHTOA. Alright, so for SOHCAHTOA, this is cancelled out. We are not using that because well, nothing is relating to the hypotenuse here, right? So we have tan theta is equal to opposite over adjacent, right? So what's tan theta? So that is tan 10 degree is equal to opposite, which is x, over adjacent. Are we going to write 1 or are we going to convert it to cm? We're going to convert it to cm. So 1 meter is the same as what? 100 centimeter. So to convert meter to centimeter, multiply by 100. It's as simple as that. Exactly. So we're going to put 100 here. Cross multiply. So 100 times split. Help me calculator. 10 times tan 10 is what again? 0.1763. Right. So what's for an answer? Just go 2 times 1. So that's 17.6. 7.2 centimeter, right? Okay, now this is the final answer, which is option D, right? Option D is correct. So like this stand, some of this stand, I need you to have them at your fingertips, especially those like those perfect ones like 30, sine 30, cos 60, cos 30. All these are, you need to know them because the calculator that we're giving to you in JAM will not have all this special keys. Is that clear? All right. So the plane mirror in a kaleidoscope are usually placed at an angle of 60 degrees. Is that true? Let's check other options before we reach a conclusion, right? So parallel to one another, perpendicular to one another at an angle of 45 degrees. Okay, the answer is very clear here. I'm sure you guys are screaming it already. And you're correct, right? So the plane mirror in a kaleidoscope are usually placed at an angle of 60 degrees. Is that clear? At angle of 60 degrees. What of periscope? Let's refresh our memory. What of periscope? Periscope is actually 45 degrees to the horizontal. Please, I know you're saying, 45 degrees what? To the horizontal. But they are parallel to each other. The mirror is what? Parallel to each other. Is that clear? So do not forget this. They are parallel to each other. Okay, let's go to the next question. Okay, a boy looks at the image. A boy looks at the image. Okay, so a boy looks at the image in a plane mirror. Okay, he observes two images, right? A bright one, and other things. The observed image results from where? It results from where? Now, there is something that you need to take note of because sometimes reading too much can make you, if you've read too much without proper guidance, without proper understanding, you might fail this question. Yes, you might fail this question. So you have to calm down. Now, what they didn't tell us there is multiple reflection. They just told us that it observes two images. That's all. It observes what? Two images. Okay. Now, this observation of two images is based on which principle? And what brought about it? Like, how did it get here? It was a reflection. Like, what's a year play mirror like this? Let your brain just come to reflection first. So what? Reflection. But there's something I want to introduce you to. Have you noticed that all the mirror in your house, right? Anywhere you see at least a mirror, you notice that it's actually thin. It's never too thick. Like it's not thick. It's not thick enough. Have you asked yourself why? Oh, you think it's because it's not be heavy? No, that's not it. Oh. Now there's something called refraction, which is the bending of light. Right? It occurs. Refraction can occur in thick glass. In thick glass. So, and when this refraction occurs in thick glass, we actually see multiple image, right, in a haphazard manner. Do you get it now, right? So multiple images are formed in plane mirror only mainly due to the thickness of the mirror. Refraction mainly takes place in lenses. Refraction mainly takes place in lenses. Is that clear? Let's go to the next question. Which of the following statements are correct for light reflected from a spherical mirror? I know you are laughing at this question. If they should give you something like this, you kill it without stress. You kill it without stress. Now, what are you expected to do in this kind of question? Analyze it. First of all, check the first eye. Incident ray parallel to the principal axis pass through the center of curvature. Ironipa, this is a lie. Yes, no. Is that true? Where did it also pass? Try. Where is it supposed to pass? Yes, principal focus. When a ray of light is parallel to the principal axis, it passes through what? The principal focus. Do you get it? Correct. Okay. Now, meaning that eye is out of it. Yes, eye is out of it. So, what of others? Let's check. Rays through the center of curvature are returned along the same path. I said this. Yes, now, when I was teaching. Check the video. Yes, now. So, this two is what is correct. Now, let's check the next one. Rays through the principal focus are sent parallel to the principal axis. This is also true. This is also what? This is also true. Yes, this is also true. So, what's the correct option? Simple and easy. Easy peasy. Easy peasy. So, C is the correct option. Let's go to the next one. Okay? I hope you're learning. I hope you're learning. I hope you're learning. Okay? So, calculate the position. Calculate the position of an image placed in front of a convex mirror. Calculate the position of an object placed in front of a convex mirror. Having a focal length of 12 centimeter such that an image is formed centimeter away from the mirror. Write out your parameters. Write out your parameters. Now, there's something I want you to take note. They say convex mirror, our enemies. Oh my God. Convex mirror. So whenever you see convex mirror, just know that the only thing that will be positive, the only thing that will be positive is you. Others will be negative, negative, negative. Do you get? Don't forget to malo gbagbe o. All right. So now they say focal length. One focal length. Focal length was minus 12 centimeter. We are writing it. Okay. So that an image is formed. That's the V. V now. Yes now. So V is what? Minus 6 centimeter. So they now ask, calculate the position of the object. That is U. Is X. U is X. Okay. So how do we get it now? 1 over F is equal to 1 over V plus what? 1 over U. All right. So 1 over F and 1 over minus 12 is equal to 1 over minus 6, right? Plus 1 over X, or let's say 1 over anyone you choose to write. So take this to the other part. We're going to have 1 over minus 12 plus 1 over 6. Is that clear? Plus 1 over 6. You know what? I think to make you can find the LCM, but there's I want to get a you can find the LCM and then get your answer here, right? But just to maintain consistency, when I was actually teaching, I brought out the formula that is getting the formula from this particular part. Exactly, getting the formula from this particular part, and we end up getting something like U is equal to FV over V over V minus F. We end up getting something of this nature. Exactly, if you can remember well. Now let's use this. Let's use it simply. So F is what? Minus 12. Right? F is minus 12 times minus 6. Okay. So we have minus 6 minus 12. Exactly. 12 times 6 minus plus, so 72 over this plus, this become plus. So 12 minus 6 will give you what? 6. Exactly. 12 minus 6 will give you what? 6. Alright, so 72 divided by 6 will give you what? 12. Use the calculator, you should be able to get this as a final answer. Is that clear? Alright, let's continue. So the question now, to produce a parallel beam of light from a concave mirror, the distance at which the lamp should be placed from the mirror will be equal to what? Okay, now this is a concept I've been treating for a long time now, I told you that light from infinity, rays of light from infinity converges that way at the focal, at the principal focus. So if we are to produce, if we are to reverse this order, that is to produce a beam of light which is parallel and maybe goes to infinity, it means that this object has to be placed, or the bulb has to be placed at where the principal focus. Exactly. Now, having this understanding, let's read the question and then get the question right. To produce a parallel beam of light from a concave mirror, the distance at which the lamp should be placed from the distance. So we're talking about the distance here, right? So we're talking about the distance here. Exactly. So if we're talking about the distance, what should come to mind? We won't just say the principal focus alone because we're talking about distance. So what we're going to include is what? The focal length. It should be at the focal length. Exactly. It should be at the focal length. So what of this? They said 2 times the focal length. No. F is equal to R over 2. Exactly. So you can't say 2 times the focal length. No, we're talking about that time. We're not talking about radius of curvature. So radius of curvature, which is not appropriate. So to keep things short, A is the correct answer. All right. So next question. Heat from the sun is used to burn a piece of paper. Right? Heat from the sun is used to burn a piece of paper with the aid of a concave mirror of radius of curvature 32 centimeter. We don't really, I don't think we need to write anything, but let's, for formality's sake, to enable the paper to start burning in the shortest time possible, right? Where do you think we should place this paper? Where should we place the paper? The paper is colored what? So the color of the paper, and also the position of the paper, right? The color of the paper and the position of the paper. Now, beam of light, beam of light from the sun or from the sun, yes, right, is more like beam of light from infinity. Where does it converge at? Can you say it? It converges at what? The focal point, right? The principal focus, I mean to say, the principal focus. Exactly. So we should know that the point is the principal focus. And the color, what color should be used? Is it white? Is it black? Is it red? Now, take note. Black is a very good absorber and radiator of heat. Is a very good what? Absorber and radiator of heat. Do you understand that? So this is the only color that fits into this. That's why, like in during the hot season in Nigeria and other parts of the world, it's not advisable to wear like black clothes. You tend to get hot very quickly. Exactly. You can wear something like white, which is more reflecting, right? It reflects more light. So the answer here is what? Black and what? The principal focus. Exactly. Now, an object is placed at the center of curvature. An object is placed at the center of curvature. So this is a mirror. So this is C. This is F. Right. So an object is placed here. So this is where the object is placed. When Anna asked what is its image is, so we're going to describe the characteristics of image produced by an object placed at C. It's very simple. First off, the image we formed here. So we have inverted image. We have same size as the object. Same size as the object. Also, we also have it's formed at C. Right? It's formed at C. So object placed at C will form an image placed at C. Is that clear? Okay, next question. Which of the following correctly describes the most suitable shaving mirror and position of the person shaving? Okay, so if we want to shave, we aim to see our whole face. Exactly. We aim to see our whole face. We don't, oh, if we are shaving, then we are seeing a very little portion. We are seeing something really, really small. It means that convex mirror cannot be used for shaving. That's the get. Because convex mirror has only one type of character. The image produced by a convex mirror has only one type of characteristics. And what is it? Can you try? Yes, it's diminished. Yes, it's what? It's erect. And it's what? Yeah, that's the two mean. That's the two mean. That's associated with this question. It means that the answer is either or it's concave mirror, but we don't know where it's going to be. Is it at the focus or is it within the focal length? Now, what does focal length stand for? Now, focal length is just from here. This is principal focus, I mean. That's F. This is what C, I mean. Now, this from here to here is what? The focal length. Exactly. This is the what? Focal length. So do not forget. So where should it be? If you were paying rapt attention to all what I've been saying, you would have chosen your answer. And yeah, we would have chosen the answer a while ago. And which is what? D. It has to be placed between F and the P. Right? It has to be placed between F and P. So we will now get what? A magnified image that is upright or erect. Anyone used to use, right? Aha. That's magnified upright and virtual. Do you get? Okay. So next question. A pencil is placed vertically between a concave mirror and its focal length. It's placed between its concave mirror and its focal point. The image of the pencil will be the same thing here. Do you understand? Which is what? Do you get the question now? It's placed between the mirror, this is the mirror, and its focal length and the focal point, which is what? F. Do you get? So let's say it's here. It will form a magnified image here. Do you get? So erect, yes. Enlarge, yes. No, not real. Erect, enlarge, virtual. Correct. So this is the correct answer. It's as simple as that. Okay, let's go to the next question. An object is placed 10 centimeters in front of a concave mirror of focal length 15. Okay, what is the position and nature of the image formed? What's the position and so now concave mirror. Concave mirror, we should know that it's always positive, except in some cases, like some cases, and where V will be negative. Okay, but most times it's usually positive, positive, positive. Okay, so object, so meaning U is equal to 10 centimeter. Focal length is equal to 15 centimeter. We don't know what V is. Exactly, we don't know what V is. So if you solve from here, you should try making V solve the formula. You should get this. I have all these formulas at my fingertips, so it's easier for me to use it. But if, for instance, you don't remember it in exam, you don't need to even panic. Just find the LCM, solve from there, make V solve the formula. You see, arrive at the same thing. Exactly. So our F is what? 15 times our U is what? 10. So 10 minus 15, that's 150 divided by minus what? 5 here, 1, that's 30. So our final answer, which is V, is equal to minus 30 centimeters. So what does this tell you? It means that this image form is what? Is virtual image. Because all real image are what? Are positive. All real image are what? Are positive. So this is what? A virtual image. So what's the correct answer here? 30 centimeters and what? Virtual. Very, 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 very simple and straightforward. Okay, the next question. An object is placed 15 centimeters in front of a concave mirror of radius 40 centimeters. The image formed is what? Okay, now let's solve the same procedure. You can pause the video. And solve. All right. Okay, now we have our U to be what? 15 centimeters. We have our R to be what? 40 centimeters. Okay, if you notice, I've actually been saying something, which is that F is equal to what? R over 2. I've only been saying that, meaning that our F is equal to what? 20 centimeters. Just 40 divided by 2. Okay, so this is a relationship between F and U. So it simply means that this formula is also applicable. You can see how this thing also comes in play, all to be treating. Okay, so what are we looking for? We are looking for what? The image, the characteristic of image form. So meaning that V is equal to Fu over U minus F. So what's our F? 20. What's our U? 15. What's our U again? 15 minus what? 20. So 20, that's 30, that's 300 divided by minus 5. We have 5 here, 1, 6. So we have 60 minus 60 centimeter. So it means that this image is virtual. Exactly. So virtual, 60 behind the mirror. So A is the correct one. Is the correct answer. Is that very clear? Okay. Let's make some progress. Let's make some progress. Okay. Next question. An object which is 3 centimeter high is placed vertically. An object which is 3 centimeter high is placed vertically 10 centimeter in front of a concave mirror. If this object produces an image 40 centimeter from the mirror, what is the height of the image? Very simple. I treated something related to this before. Okay, but let's off. We know that M is equal to V over U, right? It's also equal to image height over object height. From this question, they say the object is 3 centimeter high. So object height is what? 3 centimeter. Also, the view, the distance is what? 10 centimeter. Okay, so we now have V to be what? 40 centimeter. And we've been told to find what? The image height. Exactly. So just impute this and cross multiply and get your answer straight up. No stress. So 40 divided by 10 is equal to x over 3. So we have 10x is equal to 120 divided by 10 divided by 10. So our x is equal to what? 12 centimeter. So what we use what? 12 centimeter. Is that clear? Alright, so the next question. A concave mirror has a radius of curvature. So r is equal to what? 36 centimeter, meaning that f is equal to what? 18 centimeter. This should not be rocket science. You should know it by now. Okay. At what distance from the mirror should an object be placed to give a real image? 3 times. 3 times. 3 times. They're talking about magnification here. So whenever you see 3 times all this rubbish, they're talking about what? Magnification. 3 times the size of the what? Object. So m is equal to what? 3. Do you understand that? 3 times. Okay, so you can start something from here. You can start something from here. So now for getting the relationship between m in terms of f and u, that's the formula we're going to use, which I've actually proved in the past. I don't want to just go over it over again. Just check what I've actually explained. Now we have m is equal to what? F over u minus f. Do you get? So what's our f? Our f is what? 18. What's our u? Our u is not given now. So that's what I just find. Our u is not given. Minus what? 18. Is that clear? All right. So remember it's equal to what? 3 because we're relating it to magnification. So cross multiply, we have 3 open bracket u minus 18, right? Close bracket equal to 18. Exactly. So you can say 3u, or you can go straight to like any approach you actually want to go through, right? So you can actually go through, that is 3u minus, let me get my calculator. Okay, so 18 times 3, that's 54. That's minus 54 equals to 18. Okay, if this thing cross this part, we're going to get 3u is equal to 54 plus 18. That's 72. Right? So 72 divided by 3 will give you what? 24. So our u is equal to 24. 24 centimeter. So let me clear this place and then we'll continue. Alright, so let's continue and wrap things up. An object which is 3 centimeter high is placed vertically, right? 3 centimeter high is placed vertically 10 centimeter in front of a concave mirror. Alright, so if this object produces an image 4 centimeter from the mirror, the height of the image is what? Okay, this straightforward. First of write out the parameter. So I have the object height to be 3 centimeter. Okay, it's placed vertically 10 centimeter in front of the concave mirror. So this is like the object distance. Right, the object distance can be denoted as u, right, which is 10 centimeter. Okay, so if this object produces an image 4 centimeter from the mirror, so which is v, is what? 40 centimeter. So we're now told to find the image height. So based on what I told you earlier on, m is equal to v over u is also equal to image height over object height. So what's our v? Our v is 40 centimeter over u, then equal to I, which is x, over 3. Exactly. So we have 10x is equal to 120. So the opposite by what? By 10. X is equal to 12 centimeter. Exactly. So that's the height of the image, 12 centimeter. Alright, let's go to the next one. A concave mirror has a radius of curvature, so r is equal to 36 centimeter. At what distance from the mirror should an object, at what distance from the mirror should an object placed to give a real image um, um, 3 times the size of the object? Alright, this is a very straightforward. First of all, to get our f is what? 18. I hope that you know how I got this. You know that f is equal to r over 2. So that's how I got that 18. So like now we have like two variables or two parameters, which is okay, three parameters, which is u, f, and m. So what formula connect these three together? We have m is equal to f over u minus f. Okay, what our f is at 18. U is, we don't know what u is, f is also 18. So there are three dots digit. So cross multiply. Okay, we have 3 open brackets u minus 18 is equal to 18. So we have 3u minus, I think 72 equal to 18. It's let me calculate that a minute. 18 times 3 or 54. 54. This is 54, I mean to say. Right, so we have 3u is equal to 18 plus 54. So 18 plus 54 will give what? I think that should give 72. Okay, 3u is equal to 72. Alright, 72 divided by 3 is equal to u. So therefore, u is also equal to what? Yeah, 24 centimeter. 24 centimeter. So this is what? 24 centimeter. Alright, let's make progress. Alright, the next question we have it as an object is placed 30 centimeter from the concave mirror. So we have our u to be 30 centimeter. Okay, concave mirror of focal length 15. So focal length 15 centimeter. The linear magnification of the image is produced is what? So the linear magnification, the same average actually works here. Yeah, the same average actually works here. We're still going to use the same formula. I get them because it's basically the same like framework, the same parameters that were listed. So try something, pause the video and something on. What do you get? Type in the comment section. So we have m is equal to f over u minus f. So we have our m to be unknown. Our f is 15. Our u is 30 minus 15. So 15 divided by 15. So magnification is 1. Exactly. No SI unit, please. No SI units. No SI units. So magnification is actually 1. Okay, next one. A dentist obtains a linear magnification of 4. So we have our m to be 4. Okay, of a hole in its tooth by placing a concave mirror at a distance. So u is equal to 2 centimeter. I hope you get the logic behind all this. If you don't, type in the comment section I don't understand, and in subsequent examples I might want to keep that in. Now, the radius of curvature of the mirror is what? So we're to find r. Now, you have to be smart. Get your f first. When you get your f, you can now use get the f first. You can now use r over 2 to now like get what your r is. Now, we're still going to use this formula. Well, yeah, I'm going to use this formula. It's not difficult. So we have our 4 is equal to f over u is what 2 minus f. Okay, we have 4 2 minus f equals to what? F. So 8 minus 4f is equal to what? F. Bring like them together, we have f plus 5f and plus 4f. So we have 8 is equal to what? 5f. So divide by what? Divide by 5. Exactly. So for our f is equal to 8 divided by 5. What's that, please? Help me calculate. 1.6. Alright, so 1.6 centimeter is equal to f. But this is not what to define. We're to get our r. So we just say r is equal to what? F times 2, which is equal to 1.6 times 2, which is equal to what? 3.2, if I'm right. Yeah, 3.2. 3.2 centimeter. Do you understand? Easy peasy. Alright, let's make progress. Let's make progress. Let's make progress. Okay. So we've been given a very simple question to solve. If you've been following all through, this should be really easy for you. Now, what did the question say? Which of the following expression gives the linear magnification produced by a concave mirror of radius of curvature r? Okay, if u and v are object and image distance respectively. You just have to write down the parameters given, and then let's see how things unfold from this angle. Right, so um we have r, we have u, and we have v. Okay, I'll be very sincere with you. I like working with f, so I'll say f u v. So meaning that the formula we used last time is going to apply here, because since we're trying to find the linear multiplication, so like the normal f equals to u, right, minus f, the same stuff happens. So now let's just go straight, meaning what substitute this into the formula. Is that very clear? Okay, if you substitute it, okay, let me take it step by step. Let me not rush the process. M is equal to f, other f is what? R over 2, u minus, um, what do you call this? Other f now, R over 2. So we're still going to have something like R over 2 here. Okay, so we can get your LCM and stuff like that, yeah. So you should get something like r over 2 open bracket 2u, right, minus r over 2. Exactly. Yes, you should get something you should get something of this nature. Yes, so these two cancel these two, so therefore m is equal to r over 2u minus r. Is that clear? R over 2u minus r. Okay. So but this is not where we're going to stop. This is not among the option given, right? It means that we still have to do some like some work. Yes, we still have to do some work to see how we're going to arrive at our answer. Okay, let's try another method. Now, instead of us using u, we're going to use v. Exactly. That's m in terms of v. So it means that because if you look at this, it looks similar to this. If you are really smart, so we have to find a way to flip it. Exactly. We'll find a way to flip it so that we'll therefore arrive at this answer. We therefore arrive at that answer. Okay, so now here's what we're going to do. We're going to flip this thing. It means we're going to have m is equal to what do you call this, v minus f over what? F. This is, you can prove this, is provable, right? So m is equal to v over f minus f over f. So we have m is equal to v, right? b over f minus 1. Yeah, basically. But we won't stop here because our answer is expressed in R. So meaning that what we now incorporate is, meaning the two come up, we now have 2v over R minus 1, making what? B the correct answer. Exactly. Did you get the whole point? Yeah, just rewind it and watch it over and again. You will to get it. Okay, so the next one, the magnification of the image, the magnification of the image of an object placed in front of a concave mirror is 1 over 3. Hmm. 1 over 3. This is very, very. But now, will it be plus, or will it be plus 1 over 3 or minus 1 over 3? What do you think? It will be what? Minus 1 over 3. Exactly. If the radius of curvature is what? 24 centimeter. What is the distance between the object and the image? You just need to be smart. Like, you just need to be smart to get this. Like, I mean, damn smart. Okay, so here's the approach you're going to take. We'll try to get our U. Yeah, we'll just try to get our U first, then from there we just make up something. But now I want to give you a framework of what we're working with. Right? This is a convex mirror. Yeah, this is a convex mirror. So meaning if the object was here, we will be able to see a the object here. So we were going to find this distance. Exactly. That's what I was to find. Okay, but no pressure. Let's take it little step by step. Okay, I don't like working with R, so I'll just try to get F. So F is equal to what? Minus 12 centimeter. I told you that when I was explaining that whenever we are solving um, using the lens formula for convex, the only thing that will be positive is actually u, that's the object distance. Others will be negative. All right, so let's proceed. Going back to making use of this formula, right? That's m, yeah, f equals to f over u minus f. So we have a minus 1 over 3 equal to f is what? Minus 12 over u minus 12. Exactly. So we have this will give you something like u plus 12. So you get the gist. So minus 1 open brackets u plus 12, okay, equals to minus 12 times 3 is what? Actually to u that 6, right? Okay, so it means that we have our u to be equal to 36 minus 12. So u is equal to what? Can you hear me with that? U is equal to what? Yeah, 24 centimeter. Okay, but we won't stop there. We just got our u. We'll just try to find a way of getting our v, then figure things out. So how we are going to get our v? Please follow me. This is where I am. I'm using a black pen now. M is equal to v over u. So we have our m to be 1 over 3. So 1 over 3, that's minus 1 over 3. I will include 1 in 7. So x, that's our v, over u is 24. So we have cross multiply. We have, so it becomes 3x minus 3. Okay, no, any way you put it here, you still have the same answer. So we have minus 3. So x is equal to what? Minus 8. Exactly. S is equal to what? Minus 8. So, basically, how do we get from here to here? To get the distance between both of them, that is between this part and this part, we just need to say u minus v. Exactly. U minus v. Since from here to here is actually the distance, that's the object distance. From here to here will be what? The image distance. So what's our u? Our u is what? 24. Exactly. So our u is 24. So 24 minus, what's our v? Minus 8. Exactly, minus 8. So what do you get as the answer? 32. Easy peasy. Exactly. So this is the correct answer, which is D. Not difficult. Very easy. Okay? All right. So we have a question here. A real object is placed. A real object is placed. So for it to be a real object, it means that it's suggesting that it has to be concave. Like it has to be concave for it to be real. Because yes, for it to be real, that's unless right? to eliminate certain options. Alright, so a real object is placed at a distance u centimeter in front of a mirror of a concave mirror. Alright, so the next question. A real object is placed at a distance u centimeter in front of a curved mirror of focal length f. If the image is upright and magnified, so this object is okay. Now, a real object. So suggesting that this has to be a concave. Yeah, one is real. It has to be concave. It's because convex produces what type of image? Yes, virtual. So A and C are automatically out. That's an expo. Alright, so a real object is placed at a distance of 2 centimeter in front of a curved mirror of focal length f. So the focal length is what? F centimeter. If the image is upright. So for we to get an image that is upright and magnified, what do you feel? Sorry, I said a real object. I'm mistaking this for image, not object. I get so when it's a real object, it does not actually tell you whether it's convex or concave, please. Yes. So now why this will not be convex? Because they said what magnified. For convex, it produces what a diminished image. You should at least know that by now. Okay, so then the mirror is where we place this object. For us to get an upright image, there's only one position we're going to place this object, which is what between the principal focus and the pole. Between the principal focus and what? And the pole. Exactly. So meaning that we can rabble things around and say, all right, f over 2, because this is how it looks like, right? This is our f. So we can just say if it's here, it works. So meaning this can be correct. The object distance is f over 2. Exactly. So D is the correct answer. That's very, very straightforward and easy. So which of the following properties make a convex mirror useful as a driving mirror? Okay, I actually said this, that the reason why we use convex mirror as driving mirror is because it offers a wide field of vision. That's like the most important. And also the image form is erect. Yes, the image form is erect. So 2 and 3 is the correct option here. C is correct. Is that clear? All right. Uh-huh. Oh, I think this should be our last question. This should be our last question. So a convex mirror is used as a driving mirror because so it's more like repeating the same question in different way. Its image is erect, yes. It has a large field of view, yes. That's long for that, no. So I and I, which is what B. All right. So thank you for watching. Ensure you like, ensure you subscribe, ensure you subscribe. Thank you once more. Have a good day ahead. Bye.